Okay, so in this video, we are going to explore the new Zephyr 7B beta model that was introduced by the Hugging Face H4, and it is a fine-tuned version of the Mistral 7B model. They've already released the 7B Alpha, and I've created a question and answer generator using LangChain, so you can get this video. I'm going to put that in the description below. In today's video, we are going to explore the Zephyr 7B beta to build a RAG medical chatbot. Okay, so it was trained on a publicly data set using the DPO optimization. Okay, so the DPO, there's the article, you can go through that. It has a lot of information, but the main point here is that the DPO can fine-tune LMs that aligns to human preferences. Okay, and as well as, or it's better than the existing method, it exceeds the reinforcement learning from human feedback ability to control sentiment of generation, and also improves response quality in summarization, single turn dialogue. Okay, so you can read more about this article. All right, so let's get into some details with the model. Okay, so it is licensed under the MIT, which makes it publicly or commercially used purposes. Okay, so it has the benchmark here. You can see the benchmark scores here. All right, and as you can see on the chart here, it says that you can see how it performs with various use cases like writing. So as you can see, it is in the green line. The Zephyr 7B is in the green line. So it's reasoning, role plays. You can see how it's being ranked here, writing, humanities. You can see STEM, instruction, coding, and math. All right. So as you can see, so he says that, however, the complex stack. So when it comes to coding and mathematics, it's not doesn't really do well with that. So we're going to implement the RAG applications for this exploration, and it also has so if you want to do the pipeline, use the model, using the pipeline, you can use this code to build that. All right. Okay. And okay, so when it comes to, so these are the training parameters that they have. Okay, you can use the learning rate, the team batch size, the seed. You can use this. All right. Okay, so yeah, you can read more about it. But in today's video, we are going to use the quantized version from the block. Okay. And if you want to show you how you can download that, so you can go to files and you look for a version. I'm going to use the KM, the Q4KM for this purpose. So you can just go here and you hit on download. All right, I already have that downloaded. So we are going to implement this data set that I downloaded from the ResearchGate for this demonstration. It is defining the mental health and mental illnesses. So in place of this document, you can just use any document that you want. All right, so it has a number of pages. So we are going to implement this information, the scale of the problem, the stigma in mental illnesses, the nature and extent of stigmatization in adult mental health. All right, okay, so let's get into the Colab. So before you start, we go to runtime and you check your change runtime type. You make sure it's on GPU and you save it. Okay, so we run, ready to run this. So we need to install pip install LangChain. Well, let me rerun. Okay, install touch sentence transformers. We use the phase CPU since use the Face CPU for our vector stores. You can, the other options, Pinecone, ChromaDB, all right, and the Hugging Face have PDF, Accelerate. We're going to use the Llama CPP, right, to load the models. And we install our transformers from Hugging Face. Okay, so it's still running. Okay, so the next thing is we from langchain.chains we import the retrieval keyway to create our question and answers, the Hugging Face embeddings. All right, to create our embeddings, and we are going to need the Llama CPP. We're going to load our models. We're going to get the Zephyr 7B beta model. And the next thing is use the recursive character text splitter. We split the text into chunks, and we use the face to store our vectors, the vector store. Okay, so in this, there are other options that you can use, the ChromaDB, you can use the Pinecone, several versions. And we are going to do the PyPDF directory loader to load our PDF files. Okay, so we load, let me just run this. Okay, so now we create a variable loader. So we use the PyPDF load directory loader. So we load the content. So as you can see, we have our sample data, and I've created a folder called the data, and we are loading our PDF. So we load it here, and we say data is equal to loader.load. We load it into a variable called loader, and let's print it. So when we print it, you can see print the document. All right. All right. So it has 12 pages, as you can see. And the next step is we split the extracted data into text chunks. Okay. So we use the recursive character text splitter. We create a chunk sizes to 1,000 and the overlap to be 20. And we use the split document to split the text, the data that we loaded here. So we store them into text chunks. And so when we print the text chunks, let's see what we have. We have 52 chunks from the document, and we get the third chunk. So when we hit them, all right. So let's see. So this is the third chunk. All right. Okay. So terms used are readily understood by others. The scale of the problem and access to services is outlined. We then discuss stigma generally. All right. So the next thing is we load the embeddings, and for this one we are using the GTE, and the GTE is General Text Embeddings, which was trained by the Alibaba Demo Academy. Okay, so it was trained on large scale corpuses, and so it is applied to various downstream text example text embed of the text embeddings. It includes information retrieval. It really performs well with information retrieval, sentiment text, similarity text, re-ranking. So it has a lot of use cases. Okay, so let's get back to it. And when I run it, it's going to take a while. Okay, so we create embedding for each of the text chunks, and we use the page to store it. And from documents, so we are passing our text chunks and our embedding. So we are storing everything in the vector store variable. Okay, all right. So we need to connect to the Keta model that we downloaded. So we just connect to our drive. I'm gonna hit on connect to the drive. I'm gonna hit on this one to mount it. They say drive is already mounted. Okay, so now we need to import a model. So we are creating a variable called the LLM, and it's equal to llama. We are using the llama CPP. Okay, so we are passing our streaming is equal to true and a model path. So now we have our model here. So we are going to copy the path. So the model is stored in here. Okay, so now as you can see, you go here and you just copy the path right here and you paste it here just like that. Okay, so let me clean this up. Let me paste it. Okay, so now we set the temperature is equal to 0.7. The top P is equal to, so these are parameters that you can change depending on your use case. All right, and we make the token size to be 4096. Okay, so let me run this. Okay, so we have our model loaded here. So the next thing we have to do is, okay, so let's create our chain. Okay, so we create a variable QA passing the retrieval QA. So we pass in our models, go to the LLM, the chain types, go to stuff, and we are passing our retriever. So we want to get the top two answers. So when we run it, okay, so now let's create a query sample and say query. So how do I improve my mental health? And I'm going to hit on this one. All right, so it's this is the output. To improve your mental health, you need to focus on promoting subjective well-being, developing cognitive, affective, and relational abilities, achieving individual and collective. I think I like this response. Yeah. Okay, so let's run this one. Let's start a question. Okay, so I'm going to say, let me go here and okay, so I'm going to say, how can I reduce mental illness in children? Right, let's see. All right, so let's see. While it's true that there are interventions to reduce stigma surrounding mental illness, preventing mental illness from developing in the first place is also important. This involves addressing underlying risk factors such as poverty, trauma, and social exclusion. as well as promoting preventive factors such as strong relationships and a sense of purpose. Wow, this gives a very detailed explanation and answers. Yeah, I think I like this. All right, so this is what I wanted to share with you in this video. I do it to explore. Let me know what you think about this model. All right, if you like this, do well to subscribe, hit a like, comment, and see you in the next one.